Let's get started troubleshooting this little problem we just seem to have created for ourselves with our VLANs. And the first thing we'll do, you can check everything physical, but nothing physical changed. The ports didn't open or close or anything like that. So we're going to eliminate that. Again, let's concentrate on what we just did. Why would the creation of VLAN 100 have caused this issue? If we put the ports in the same VLAN and they're still in the same subnet, everything looks good from there. So what is the problem? Well, let's go over to our switches that we just configured. And we run show VLAN brief because maybe we mistyped something and one of them is VLAN 10. We could have done that. We run show VLAN brief and there's port 1 right in VLAN 100, right where we thought we put it. So that checks out. Now let's go over to our other router. Excuse me, our other switch, I apologize. And let's do a show VLAN brief. Show VLAN brief. And there's port 3 right in VLAN 100, right where we thought we put it. So here's the real puzzlement. Everything looks good. These ports are in VLAN 100. We didn't change their IP addresses. We didn't shut anything down. So what happened? Well, with troubleshooting, there's nothing wrong with starting at the endpoints of a network, where we did the configurations. But what about the middle of this whole thing? What about this switch 2? Let's take a look at that and see if switch 2 knows about VLAN 100. And it does not. It has nothing here about VLAN 100. And this is one reason we really need VTP, is to let all the switches know about all the VLANs that exist, even if the switch doesn't have any ports in one of those VLANs. And in this case, switch 2 does not have any ports in VLAN 100. So we need a way to let it know without going to the switch and saying, well, okay, let me type in VLAN 100 and everything will be fine. Now, you might ask, well, why didn't we have that problem before with VLAN 1? Well, the thing is, all the switches know about VLAN 1 because it's the default VLAN. 1 and 1002 through 1005, all the switches know about that. And here's what happened at the very beginning of our lab. Switch 1 sends frames out for VLAN 1, switch 2 gets them and says, hey, I got no problem with that. I got VLAN 1 in my VLAN database. I'll act accordingly, and the host got it, so we saw pings actually go through with no problem at all. The problem came in where we moved the host to VLAN 100, because now switch 2 is getting something for VLAN, a frame tagged VLAN 100, and says, hey, I don't even know VLAN 100 exists. And we look in the VLAN database on switch 2, there's nothing there. So switch 2 just says, hey, what do you want from me? I'm dropping it. And that's exactly what just happened. Now, again, we could create VLAN 100 manually on switch 2. And I'm going to show you how we would do that without putting a port into the VLAN itself. But I'm not going to hit enter because I want VTP to do the work during our lab. But if I put VLAN 100 in right there and hit enter right now, the VLAN would appear here, and then connectivity would be restored. Everything would be lovely. And in a 3-switch network, it's not a big deal, right? It's a small network. It would be easy to keep up with. But what about a 300-switch network, or even just a 30-switch network? Statically creating VLANs on every single switch in our network is not a scalable solution. It's not something that you and I, the very, very busy network admins, want to take care of. If we have 30 switches and we've got one VLAN that just it really has hosts on 2 of the 30 switches, we don't want to connect manually to all other 28 switches and go, okay, VLAN 100 tap, VLAN 100 tap. It's not a good use of our time. And of course, the more manual configuration you have, the more manual misconfiguration you have. All you've got to do is get a little bored, because you're going to get bored typing VLAN 100 that many times. And you're going to type VLAN 100, VLAN 100, and sooner or later you type VLAN 10, and you hit enter and you don't notice it. And then later you end up doing more troubleshooting because you end up with a connectivity issue because of one simple mistype. So it is much better for us to let the VLAN trunking protocol, VTP, do the work. When we put all 3 of our switches here into the same VTP management domain, it's generally just called the VTP domain, but the full name is VTP management domain. They will exchange information about the VLANs they know about, and what we end up with is that every switch has a synchronized view of the VLANs on the network. And this would be true for 3 switches or 30 or 300 as long as they are in the same VTP domain. And at that point, our host in VLAN 100 can communicate without us having to go to switch 2 manually and enter VLAN 100. So let's go ahead and take a look at that. Let's go ahead and make that happen actually. And we will join them all to the VTP domain CCNA. Clever, huh? The command we want here is VTP domain, not a whole lot of options here. And we get a little message changing VTP domain name from null to CCNA. I know I don't want to tell you this, but I'm telling you anyway. That does not mean that the previous domain name was actually null. Okay, what it actually means is there just wasn't one. So it went from null to CCNA. We got a little syslog message there on top of everything else. VTP domain name changed to CCNA, and therefore we're still going to verify it, even though we know we've got 2 confirms here, but we're going to verify because I want to show you another command, and it's called show VTP status. Now, I do want you to get used to the fact that sometimes, you learn the output of a command and then you go on a live device and it's like, wait, this is a little bit different. The outputs we're going to see in this lab are a little bit different because I made sure to put some different hardware in there. I just want you to see that it can be a little bit different with show VTP status. And, you see from the top VTP version capable, so this one can run versions 1 to 3. It's running version 1, and the VTP domain name is CCNA. Now, it's an interesting thing. I want to mention this. Before you join a VTP domain with a switch, if you run this command, you're going to see almost all of this information. It's not like the usual show thing where if you haven't configured something and you run show, it shows you nothing. It's going to show you all of this, except this field will be blank. That's what you got to watch out for, because it's easy to run show VTP status and say, wait a minute, it must be running, I got all my stuff. Well, if you don't have something here with domain name, then you got a problem. Actually, you're just not in VTP. So what we should do at this point, before we wrap up this video, is head over and join the domain. Let me show you that though. I'll run show VTP status before we join a domain. And you can see this output's a little bit different. Has much of the same information. We go to the top, running VTP1, it's VTP2 capable. So this one doesn't look like it can run version 3. We'll chat about that later. Config revision, we're definitely going to be chatting about that. Number of existing VLANs, VT operating mode, plenty of info coming about that. But look at this. What in the world is going on here? This switch is haunted. Actually, it's not haunted, but this is the expected behavior. But I promise you, I did not make this switch join the VTP domain CCNA before we started this video. It's there. So, but we didn't configure it. How did it join? Well, let's go over to switch 3 and see what's going on there. See if we've got 2 haunted switches. And we do, because this one has already joined the domain name, domain CCNA. But we only configured it on 1. How did that happen? We're going to talk about that at the beginning of the very next video and go from there.